Hello again, everyone. I hope you're doing well with e-learning and enjoying our time off as much as possible, but learning a lot. Today, we're going to continue learning about wind energy. Our objectives for today, again, is to review what is wind, and then to learn how wind energy works. How do we take wind and generate electricity to power our world? We're going to find that out today. Now, as a quick review, wind is simply air in motion. It's produced by the uneven heating of Earth's surface by the sun. As the sunlight, the heat from the sun, hits the Earth, it begins to warm air molecules. And as those air molecules warm up, they begin to move faster and further apart, causing them to rise. The air higher in the atmosphere is cooler, and it begins to sink. Thus, we get wind movement. All right. So some parts of the Earth are warmer, other parts are cooler, constantly causing air to move. Now, because of this movement, we know that cool air causes high pressure systems as it sinks, and hot air causes low pressure weather systems as it rises. So again, to reiterate, that rising of warm air and sinking of cool air causes wind. It's wind and air pushing itself across the Earth, again, due to the uneven heating and cooling of the Earth. Now, how do we take wind and create electricity? Well, wind energy is turned into electricity by wind turbines. I don't know if you've ever seen a wind turbine, perhaps as you travel around the country or around the world. We have a variety of sizes. Of course, the big ones you may see in the countryside are what generates a substantial amount of electricity, but smaller wind turbines, perhaps in the city, can do the same. So what we want to know is how these work. So to begin, a wind turbine is a mechanical device. It's a machine. And that machine takes the kinetic energy of the wind and it turns it into motion energy and then electricity through the following steps. Now, before we begin, if we look at the picture on the right, we see our wind turbine and wind flow. Right? Wind is flowing over the blades of the turbine, causing lift and drag. This is just like the turbine we discussed in class, where the wind, or the steam as the example was before, causes pressure on the blades, causing them to move. So keep that in mind as we go forward here. So back to this. How do we turn wind into electricity? Well, step one, wind is caught by the blades and spins the rotor. Okay, again, wind is caught by the blades and spins the rotor. Now, let's think about this in a way that might make it a little easier for you. So I want you to think of it like catching a ball. When you catch a ball, you absorb the energy as the ball stops. Okay? When a ball is moving, say, through the air, like you're playing basketball or baseball or whatever, it has kinetic energy. It has motion energy. As soon as you catch the ball stops, and it does not have the kinetic energy it once did. But you absorb that energy as it stops. So I want you to think of it in a bigger scale. So imagine wind as millions of particle-sized balls, and they hit the blades of a wind turbine. Now the blades absorb that energy, just like you would catching the ball. And the energy carried by those balls pushes the blade and it begins to move. This is how wind spins the blades of a wind turbine. So, for a little comic relief, all right, think about absorbing the energy of a moving ball. Kind of like this. Woo! There we go. So what's happening is the energy of the ball moving is absorbed by the little boy, causing him to fall down. Now, we want to consider this in terms of wind, okay? So, here we've got another image. You see the wind is moving from the right, and it's moving over the ball or the sphere there, or the circle for that matter. And as it moves over that ball, you can see that it slows down, okay? So you've got wind moving at a certain speed. As it impacts the ball, it slows down. Same thing here. This is an actual wind turbine, as you can see. At least I hope you can see. Both images show wind moving across the blades and past the wind turbine. Now, the orange or the red signifies the movement of the wind. Again, it's moving a certain speed. As it impacts the blades of the turbine, it slows down. And we see the slower wind behind the turbine in green. Okay? So, again, to reiterate, the kinetic energy of the wind is being absorbed by the blades of the wind turbine, making them move, and in the process, slowing down the wind. Now, the second step, the rotor is connected to a low-speed shaft which turns. The low-speed shaft is connected to a gearbox. And this is pretty critical because within the gearbox, a large, slow-moving gear turns a small gear quickly. Now the gearbox increases the rotation speed of the blades from 18 revolutions per minute, which are RPMs, revolutions per minute, or basically how many times it spins in a minute, to 1,800 RPMs. Now, high RPMs are necessary to produce electricity, as we'll see in a moment. So what does this look like? Looks like this. We see the bigger, slower gear turning at 18 RPMs, and the smaller gear, which is connected to it, is spinning faster at 1,800 RPMs. Now this is a little example. It's not really spinning 1,800 RPMs. But it gives you an idea of how one big gear allows for a smaller gear to move more quickly. Now, if we move beyond this, third step here is that the small gear turns a high-speed shaft. Step 4, that high-speed shaft is connected to a generator. Okay, we've talked about generators before. But again, as the high-speed shaft turns the generator, it produces electricity. Okay? If you remember from our discussion on generators, we need that high-speed movement in order to produce electricity efficiently. From there, simply put, the electricity is sent down the turbine tower to a transformer, which then sends it out on power lines to homes and businesses. Okay? Now this is how it works in the technical aspect, let's say, but there are some factors we need to consider and understand to generate electricity from the wind efficiently. Oh, I'm sorry, here's another example. All right, again, the wind is being absorbed, which causes the rotor to turn a large gear slowly, which is connected to a smaller gear spinning quickly, connected to the generator, and the generator is creating electricity. Now, in terms of the factors I alluded to, so wind turbines are most efficient when they are built where wind blows consistently. So we want wind to be blowing or air to be moving often, regularly, every day if possible. In addition, that wind must blow at a minimum of 13 to 26 kilometers per hour. Faster winds generate more electricity, but if it is too fast, electric generation can decline. So on average, wind turbines are about 80 meters tall because wind high above the ground is stronger and steadier. That means it's possible to capture more of the wind's energy and make our turbine more efficient in the process. Now, we have to understand, and I'm sure you can understand, that wind turbines cannot generate electricity all the time. This is because wind is not always blowing. All right? We have windy days and we have still days. That being said, wind turbines work between 65 and 90% of the time. Okay, so think about that. So of the year, these turbines are working 65 to 90% of the year. So when wind turbines are working, they are only able to convert about 25 to 45% of the wind's kinetic energy into electricity. So you have to consider that 55 to 75% of the energy the wind has isn't able to be converted. It's not good, but it's not bad either, okay? If we're getting 45% of the kinetic energy and creating electricity from it, that's great. That's a good amount of energy. Now, you may think, that's only capturing maybe less than 50% of the energy. That's not good. But it is, because wind is the fastest growing energy technology in the world today. And over the past several decades, it has improved and become cheaper, and every day it continues to improve. It continues to become cheaper. And the best part is that wind energy is a clean fuel, because wind turbines produce no air or water pollution. So today we did a little review of what is wind, and we learned how wind turbines capture the kinetic energy of the wind and turn it into electricity. Again, I hope you've followed along on the worksheet. Please don't forget to complete the attendance questions. They are required for your grade. Okay? And if you have any questions, please post them in the forum. I will do my best to answer any questions posted there. All right? Thanks so much. Next week for e-learning, we will continue talking about wind turbines, specifically how they are designed in order to be as efficient as possible and create as much electricity as possible. All right. Thanks, everyone. Have a good day.